We are at day 5 of Unit 5A, solving exponentials without a calculator. This is the last lesson, new lesson before spring break. We're getting there. We're getting very close. So as an example, very trivial, very easy. 3 to what exponent x will give us the number 9. This is really easy. Everyone knows x equals 2. Okay, but what we should do is think about how I can redo this. I can rewrite this using the same base. So if I want to rewrite this, I would say 3 to the power x is equal to 3 squared, because that's what 9 is, just 3 squared. And we see we have the same base, and the exponent on this side has to be the same as that side. And we got x is equal to 2. So the idea is we want the same base. Let's call it capital B, and capital B raised to the exponent m. When it's equal to capital B to the exponent n, that means the two exponents have to be equal. And that's what we're going to try to work today with. And that's what it says right here. Getting things with the same base. So we need to know our rules of exponents from Algebra 1, and that when we multiply bases, multiply powers, we add exponents. When we divide powers, we subtract exponents. When we do a power to a power, we multiply exponents. And I said I wrote it correctly. And something raised to the negative exponent is really 1 over something raised to the positive exponent. Okay. We need to know your powers. You should know like 5 to the 3rd is 125, 2 to the 4th is 16, stuff like that. And for all these problems that we're going to do, we're going to look for a common base. That's the key. Some base they have in common to make my life easier. I made the first one very easy. 125 is really just 5 to the 3rd because this already has a base 5. So I have 5 raised to that exponent is equal to 5 to the 3rd. Same base cancels out. 2x minus 4 is equal to 3. Add the 4, divide by 2. X is equal to 7 over 2. Now for this next one, we have to figure out what would be a good base from the number 8 and number 32. So I think a good base for this one would be base 2. This is 2 to the 3rd is what 8 is, raised to the 4x is equal to 2 to the 5th. And I get, when I see this, I multiply exponents. 2 to the 12x is equal to 2 to the 5th. They are the same base now. 12x is equal to 5. X is equal to 5 over 12. So we've done 2 problems here, and actually I'm going to show you that they should check out on the calculator. Everything should be able to be proved on the calculator. So for my first example, my solution was 7 over 2, so I do 5 raised to the 2 times 7 divided by 2 minus 4. And we do get 125, and the next one was, my solution was 5/12. So 8 raised to the 4 times 5 divided by 12, and I get 32, so they both check out. So when you're done, you could check to see on the calculator if you get a proper solution. For this next problem, a good base I think would be 3. So 3 squared is what 9 is, raised to the 2x plus 1 is equal to 3 to the 3rd. I'm going to multiply my exponents. 3 raised to the 4x plus 2 is equal to 3 to the third. Now I get my same base, which is what I'm trying to do, so I can cancel them out. 4x plus 2 is equal to 3. 4x is equal to 1. X is equal to 1/4. That is my solution. This next one, I think a good base. You could use 2, but I might as well use 4. Makes my life a little bit easier. I don't have to rewrite that second one. I can multiply my exponents here. 4 raised to the 6x minus 8 is equal to 4 raised to the x plus 7. My bases cancel out because they're the same. 6x minus 8 is equal to x plus 7. I could bring the 8 over to the other side to make it equal to 15. I could bring the x over to the other side and make it 5x. X is equal to 3. For this next problem, I think I'm going to use base 3, so 3 to the 6x plus 3 is equal to, well 3 squared is 9, so 3 to the negative 2 was 1 over 9. Negative exponents makes that reciprocal. They are the same base. 6x plus 1 is equal to negative 2. 6x is equal to negative 3. Divide by 6, I get negative 3 over 6, or negative 1/2. And for this next one, I think I'm going to use base 5, so this becomes 5 to the negative 2. 5 to the negative 2 raised to the 2x minus 5 equals 5 to the third, because that's what 125 is, raised to the 2x. So it's all finding a good base and knowing your powers. 1 over 25 is 5 to the negative 2. 125 is 5 cubed. I can multiply these out. 5 to the negative 4x plus 10 is equal to 5 to the 6x. My bases cancel. Negative 4x plus 10 is equal to 6x. I could add the 4x to the other side. I guess 10 equals 10x, or x is equal to 1. Like I said, if you want, when you're done, you could plug 1 or any of the solutions back into the original problems to see if you get something that works out to be true. But it's really just finding a same base. So these look a little bit different. I think maybe I should try to do this whole isolate, where I get b raised to an exponent is equal to some number, and then I could do my magic of the same bases. So for this one, the first thing I'm going to do is divide by 20. I get 2 raised to the x over 3 is equal to 1/4. And I should rewrite this as 2x over 3 is equal to 2 to the negative 2 power. If 2 squared is 4, 2 to the negative 2 is 1/4. Same bases. X over 3 is equal to negative 2. Get rid of this 3 on the bottom by multiplying on 3. X equals negative 6 is my solution. Same thing, divide by 36. I get 1/3. 5x plus 2 is equal to 1 over 9. Now I could use base of 3 and make this 3 to the negative 1, but 1/9 is really just 1/3 squared. My base could be a fraction. As long as they are the same base, all's good. If you want to rewrite it as 3 to the negative 1, go right ahead. It's not going to help you. 5x plus 2 is equal to 2. 5x is equal to 0. X is equal to 0. 0 is a number. It has rights. You can have the solution of x equals 0. I'm going to do the same thing here. I'm going to divide by 3. I get 25 negative 2x over 3 is equal to 5. I think my base should be 5, so this becomes 5 squared raised to the negative 2x over 3 is equal to 5 to the first. I'm going to multiply this out. I get 5 to the negative 4x over 3 is equal to 5 to the first. 5's cancel. I get negative 4 over 3x is equal to 1. And again, when I see a fraction in front of the variable x, I just multiply by the reciprocal. And I notice that these cancel out. I get x is equal to negative 3/4 as my solution. Now for the next one, I'm going to do the same thing. I'm going to divide by 5. I don't really like dividing by 5 here. Instead, I'm going to multiply by 1/5. I'd rather multiply by 1/5. The 5's cancel. 2 to the 2x minus 7 is equal to 1/8. When you multiply that out, I can rewrite it as 2 raised to the 2x minus 7 is equal to 2 to the negative 3. These cancel out. 2x minus 7 is equal to negative 3. 2x is equal to 4. X equals 2 is my solution. So you got to remember what your powers are, especially when you have a fraction. Find this last couple one, a lot more is going on here. So when I multiply these two things, I need to add exponents. So it becomes 5 to the 6x minus 1 is equal to 5, 3x plus 11. When you multiply powers of the same base, you add exponents. I do have the same base. 6x minus 11 is equal to 3x. 6x minus 1 is equal to 3x plus 11. I could bring the 3x over. I could bring the 1 over. I get x equals 4. Finally, this last one, I think I just had to do a lot of reworking. I should decide what's a good base for this one. 16, 1/4, 32, 1/2. I think the base is 2. 2 to the 4th exponent, 2x minus 5, times 2 to the negative 2 exponent, 3x plus 1, equals, I'm going to change color here, 2 to the 5th times, this is 2 to the negative 1, exponent x plus 3. And now I'm going to multiply all these exponents out. 2 raised to the 8x minus 20 times 2 to the negative 6x minus 2 is equal to 2 to the 5th times 2 to the negative x minus 3. Again, I have same bases here. 2 raised to the add exponents, 2x minus 22. And I have the same thing over here. 2 negative x plus 2 when I add my exponents on that side. I have a nice same base. 2x minus 22 is equal to negative x plus 2. I could add the x to the other side to make it 3x. I could add the 22 to make 24. And for my final solution, I get x is equal to 8. And I could put that back in the calculator to see if it all works out. Didn't need much of the calculator today. Made it a lot quicker. But this is, we're not in class, so you're watching this video. You have all day to do that daily assessment, and the homework is due on Monday. We have a group quiz on Monday. You can hit me up with an email if you have any questions, but I will be out part of the day for the vaccination. Okay, good luck.